Very good morning to everyone. So we will continue our topic. We are studying the chapter sound, and we have discussed the what is sound, that is form of energy. Sound is produced due to the vibration of the materials or objects, and we have discussed the common terms in sound, that is uh, amplitude, that is vibration, frequency, units of frequency, and also time period. We have also discussed that time period is reciprocal of frequency, means they are reciprocal to each other. Okay, and we have discussed the range of sound or according to their frequency, that is infrasonic. Okay, uh, that is another one's sonic vibration that can be heard by the human beings. That range is from 20 hertz to 20 hertz to 20,000 hertz, and that is ultrasonic. Okay, that is greater than the 20,000 hertz frequency, having greater than 20,000 hertz. Okay, and now we have also discussed how bats and the dolphins which locate their prey. So bats produce ultrasonic waves. Suppose there is a bat. This is a bat. Okay, and it produces ultrasonic sound like this. And suppose there is an insect here. This ultrasonic sound can't be heard by human being also, and neither insect also can't hear the ultrasonic sound. Okay, so bats produce the ultrasonic range. Okay, after it, the sound strike with the insect and reflects back to the ear of the bat, so they can locate their prey and eat it. Okay, in the same way dolphins hunt their prey by producing ultrasonic range, ultrasonic sound. Okay, now we will discuss reflection of sound. So from here we have calculated that sound reflects from a medium. Okay, so uh, we have means from here we have calculated sound reflected from a medium. Now absorption of sound means what happened when we put materials like curtains, okay, and gunny bags, straw, carpets. So what they do, they just absorb the sound. When you have been to the theaters, multiplexes, cinema hall, what happens? There are curtains are set up, or like carpets everywhere. Why this is set up? Because when we watch movies, the high volume speakers are set up, that so that sound can reach to the last one who is sitting in the at the last. But when sound is produced, there will be reflection of sound. So to absorb this sound, this material are fixed, that's carpets, curtains, gunny bags. Okay, so they absorb the sound, so no reflection of sound, no echo is produced. Okay, so absorption of sound. And which type of material absorb the sound? Curtains, carpets, gunny bags. Now, that's why the big cinema halls, auditoriums are carpeted and their walls and coated with some rough materials so that sound cannot reflect. If the sound will reflect, they will produce echo and there will be a disturbance. When same sound will be repeated after some interval, so we will face difficulties. Okay, if we are hearing the same sound after some time and we have to hear the next thing also. Suppose an actor is delivering his dialogue. Okay, suppose an actor is delivering his dialogue, is saying something, first line. If the sound is not, if sound gets reflected, the first line will get reflected to your ear. Okay, first you listen the sound, after you listen the echo of the sound, in the reflection of sound, and in the next line he also says something. So two things you will hear, means things you will hear, two different things you will hear at the same time. What happened? You will not able to understand. So sometimes when you are with your friends, 5 to 6 friends, two friends will means speak at the same time. What you say? Just speak at one at a time. so you can hear it properly and understand it properly. Okay. Now, what is echo? Echo is a reflection of sound. And where is echo heard? It is observed. Echo is heard at the high-rise buildings. When we go to the hilly areas, there is too much space. Okay, and when you shout something, your name, what happens? After some times, the name will get reflected from the mountains, hills, and it will come after some time to your ears. So that is echo. Okay, and okay, my question is to 8D Prisha Tibrewal. Can you hear me? Prisha Tibrewal. This is not responding. Prisha. Okay. 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 My next question. Okay. Suryansu 8A. Can you hear me? Suryansu.
Yes, sir.
Okay. Tell me the speed of sound in air.
332 meter per second.
Okay. Okay. That's good. Very good. Okay. The speed of sound is 332 meter per second in air. Okay. Speed of sound. And one thing more, that human ear can, okay, Mohammed Shadab, you can lower your hand. When I will ask you a question, you just answer. Okay. So human ear can hear two sounds. Means our ears can hear two sounds, two different sounds at the gap of 1/10 second. Means suppose two sounds are coming. Okay. And the gap between them is 1/10 second, so they can hear properly. Okay, suppose this sound is coming at 5 second, means fifth second, so the another sound will come at 5.1 second, so we can hear the two different sounds properly. Okay, now see here the time gap. Now I'm calculating something. See here, speed of sound in air, speed of sound in air is 332 meter per second. Okay, and I am want to calculate minimum distance for echo. Okay, suppose a person is standing here and there is a something like hill areas or some wall which can reflect the sound. Okay, he speaks something, the sound will strike here and return back to his ears. Okay, suppose the distance between the man or the source of sound to the reflector is x. Okay, so how much distance the sound will travel? First it will goes to the this reflector, so it will travel x distance. Now it will again follow the path. After reflecting, it will again come to the ear of the source of sound, means speaker. So the total distance traveled by the sound is, first it goes here x distance, then it returns to the x to this ears. So total distance is total distance is equals to 2x. Okay, now time gap, what should be the time gap between the two sounds? We have for hearing human ears 1/10 second. So we know the formula of speed. Okay, speed, we know the formula of speed. Let me ask question to the to someone. No, you know the formula. I know. Shadab will know. I will ask. I want to ask Akriti 8A 4997. Can you hear me? Akriti 8A. Okay, not responding. Okay, Kanha 8B. Okay, Anubhavdeep Gupta. Anubhavdeep, can you hear me?
Yes, sir.
Anubhav. Okay, tell me formula of
Sir,
speed.
distance covered by sound upon.
Okay, distance upon time.
Sir, distance covered by.
Okay, distance upon time.
Yes.
Speed is
Yes.
okay. If I want to calculate distance, so what will be the answer? Distance is equals to okay.
Mm,
Okay, who will answer is Abdul.
1 minute.
Okay, Abdul, tell me what is distance?
It's a speed into time.
Very good. Speed into time. Okay, Abdul, tell me the speed of sound in air.
It's a speed of sound in air is a 332 meter per second.
And what is the minimum time gap between the two sounds so that human ear can hear it?
So what minimum?
Minimum time gap, time interval. I have told you minimum time interval gap for two different sounds so that human ear can hear it properly.
Minimum.
Okay. Anyone else? What is the minimum time gap? Okay, Alina.
So 1/10 seconds.
Okay. So minimum time gap is 1/10. So here, from here, we are calculating the minimum distance for the echo produced. Okay, because echo, what is echo? Reflection of sound from a reflecting medium to the speaker, to the source of sound. So here, 332/10, 10 decimal will place here, 33.2 meter. So this 33.2 meter is what? That is 2x, because the gap between the source and reflected is 1/10. The first sound gets here and it goes to the ear of, means to the ear of this man. Okay, so the total distance will be 33.2 meter. And what is the distance between the speaker and the reflector? Means sound travels 33.2 meter minimum to, so that a human ear can hear it. So what is the distance, this x distance? Total distance is 2x, and we have calculated 33.2 meter. So what should be the minimum distance between the speaker and reflector so that echo can be produced? Okay, I'm asking in different way. Maybe you have confused. This is a man. Okay, this is a reflector. If you speak something, what happens? The sound gets strike on the this reflector and return back. Okay, first goes here, then return back to the here. Okay, this total distance we have calculated, because first speed of sound is 332 meter per second and time gap is 1/10 second. So these sound first goes strike on here and reflect to the ear of the man. And the total distance of sound travel, total distance means first here, then return, means first home to school, then school to home. That is 33.2 meters. And we have to only calculate the minimum distance between the reflector and the speaker. And this 33.2 meter is, we have calculated total distance traveled by the sound. So what is the bus minimum distance, I'm asking? Okay, Alina.
16.6 meter.
Okay, 16.6 meter. Okay, Uma, you tell me what is 33.2, even or odd?
33.2, it is odd.
Odd, okay. See, it is an even number. The number having last digit 0, 2, 4, 6, 8 are even. Okay, so this is even number, not odd number. Okay. See, so the minimum distance between the source and the speaker, the speaker and the reflector is 16.6, and we are taking approximately 17 meters. So for the first condition to produce echo is minimum distance between the source of sound and the reflecting body, that is reflected, is 17 meter. We can say write 16 meter also, but we are taking approximately 17 meter. Okay, and for producing echo, if I speak very low, very deep, so what happened? The sound will not go here. if this speaker is speaking very dim, so what happened? Sound will goes is speaking very dim, very low. Sound will reach here only. It will not go to the reflecting body. So the loudness of the sound enough to reach to the reflector. Okay. So loudness of the sound should be sufficient so that it can hear after reflection. So there are these are the conditions for producing echo. Okay. And what happens if there is a curtain or something else? So there will be no echo because sound will get absorbed and there will be no reflection. Okay. Now we have understand about the echo and the condition for the echo. Okay. Now to calculate the depth of the seep, suppose it is a sea. And there is a boat, and in boat there is a system fitted which produce ultrasonic sound. Okay. And it is this method is called sonar, not goldsmith, sonar. Okay. And what is sonar stand for? Sound navigation and ranging. Okay. So this boat produce ultrasonic sound, and after striking at the depth of the sea, suppose it is a depth of the sea, D or X, whatever you want to assume. I'm assuming X. After striking, it will goes to the boat. Okay. And they will record the time, in what time this sound is reflecting. Means after reflection, it comes towards the boat. Okay. So first it goes here, then it returns back to here. So suppose first it is taking time T to reaching to the depth of the sea, and it takes the same time to reach to the bottom of the boat T. Now I'm giving you a question and you have to solve at the same way we have calculated the minimum distance of echo. Okay. So my question is to okay, Abdul Rahman, can you listen me? Can you hear me?
Yes, sir.
Okay. I have told you, means we have discussed the speed of sound in air is 332 meter per second. Okay.
Yes, sir.
So what is the speed of sound in liquid, that is water? Greater than 332 or less than 332?
Sir, in liquids are less than 332.
Okay. Okay, Alina, you tell.
So more than 332 because it travels faster in liquid and solid.
Okay, Vaishnavi, what is your answer?
Sir,
Greater than
more.
more
Sir,
than.
greater it is.
Okay, very good. So the speed of sound will be greater than water, and it is about 1500 meter per second, 1600 meter per second. So I'm giving you speed of sound in liquid is 1600 meter per second, and you have to solve. Okay, 1600 meter per second, and it takes total time, means from reflecting, means the depth of the sea, and return to the bottom of the boat. It takes total time T is equals to 8 seconds. Okay. Now you have to calculate the depth of the sea. Depth of the sea. Okay. Who will answer? Okay. Who will answer? The depth of the sea. The speed of sound in water is 1600 meter per second, and the total time taken to reach the sound, means after reflecting to the bottom of the boat is 8 seconds. And now we have to calculate the depth of the sea. Okay, Abdul Rahman, what is the answer?
Sir, 200.
200. Okay, Vaishnavi.
Sir, 12,800 meter.
12,800 meter. Okay, okay. Shaurya Pandey.
Sir, 6,400.
Okay, Shaurya Pandey. Okay, Alina.
Sir, 12,800 meter.
Okay, and Shreya Chaurasia. Yes, what is your answer?
Sir, 200.
200. Okay, see here. Most of the student has answered correctly. Means out of 6, 2 have answered correctly, and one has done mistake. See, their total time taken. We have to calculate. I am giving you one more example here. Suppose you go from home to school. Home to school. Okay. And you go to the school. Okay. And you return to the school. Total time taken is 4 hours. And you have to calculate the distance between home and school. Okay. And your speed is 10 kilometer per hour. Okay. Speed is 10 kilometer per hour. And you have to also only calculate the distance between home and school. So see how you calculate. Speed is equals to distance upon time. Okay. Speed is given 10 kilometer per hour. And distance we have to calculate. You take total time for going home to school and school to home. This total time. For one way, the time is only 2 hours. Okay. For one way, time is only 2 hours. So time is 2. So the distance between your home to school is 20 kilometer. Now, in the same way, we will calculate the depth of the sea. See, the total time taken by the sound is 8 seconds. But we have to calculate this much distance, this x, and for traveling x distance, it takes half of the 8 seconds. That is time equals to 4 seconds. Okay, and we will use the formula speed equals to distance upon time. Speed of sound in air is given 1600. Distance we have to calculate. Means distance means this depth. That is, we have taken x, or we can take d, depth of the sea. And what is time? Time for only one, from bottom to the depth of the sea. That is 4 seconds. 1600 into 4. 16 4 is 64. Distance is equals to 6400 kilometer. Okay. So, if you have no doubt, you can lower your hand. Vaishnavi, Anubhav, and okay. So this is the not meter, 6400 meter. Okay. So this way, the sailor calculate the depth of the sea by sonar method. The sonar is fitted in at the ships. They produce ultrasonic sound, and after striking to the depth of the sea, they reflect it back. They record the time period, and they calculate with the formula, and they get the depth of the sea. Okay. So I have given you one question. Only 3 students have sent me the solution. Out of 2 is correct and 1 is wrong. Okay. I've given you this question. Square of side 10 meter. Okay. And there is a block and 10 Newton, 10 Newton. Okay. We are applying force 10 Newton. And from A, B, C, we displace this block from A to C. And what is A to C? The diagonal of the square. And we have studied in geometry, what is the diagonal of square? √2 multiplied by the side. Means if the side of a square is A, what will be the diagonal? √2a. Okay. So what is the distance between A to C? Side of a square is 10 meter. So what is the distance? 10 into √2. 10 into √2. Okay. Vaishnavi has answered, Alina has answered, and one more student sent the solution, but his answer is wrong. Okay, who will tell me the value of √2? Okay, sure, Pandey, tell me value of √2.
Sir, 1.414.
1.414. Okay. Who will tell me the value of √3? Other than Shaurya. √3. No one other than Shaurya. Okay. Yes, Alina.
1.73205.
What is the value of √4? Value of root 4 is 2. Only 2. Value of root 4 is 2. Okay.
Yes.
See, so 10 root 2, 10 multiplied by 1.414, that is 14.14. Okay, this distance, displacement means this distance between A to C, meter. Okay, now we have to calculate the work done. What is the work done? Force into displacement. What is force? 10 Newton, and into 14.14, that is 141.4 joule. Okay, that is the answer. And for today the homework is, see, the kinetic energy of a body, kinetic energy of a moving body having velocity, kinetic energy of a body velocity equals to 5 meter per second is, sorry, this question is wrong. Kinetic energy of body having velocity equals to 18 kilometer per hour is 100 joule. Is 100 joule. Kinetic energy of a body having velocity 18 kilometer per hour is 100 joule. Okay, and if the velocity is increased to 72 kilometer per hour, so what will be the final kinetic energy? What will be final kinetic energy? Okay, solve it and send it to me. You can take a screenshot if you didn't write the question on your mobile. Okay, so I'm dictating the question one more time. Kinetic energy of a body moving with velocity, that is 18 kilometer per hour, is 100 joule. Means the kinetic energy of that body is 100 joule, which is moving with velocity 18 kilometer per hour. And for the same body, the velocity is increased to 72 kilometer per hour. Okay, what will be the final kinetic energy? And we have to calculate the final kinetic energy. Here velocity is increasing, so the kinetic energy is also increased. So I have to calculate, solve it, and send it to me. Okay. Okay, thank you, class. This is all about today. If you have any doubt, you can ask me. Thank you for today.